So, hi everyone, thank you for joining this meeting. My name is Atharva. Today I want to talk about some of the main ideas behind the AI technology we see everyone right now. We all hear a lot about AI and a large language model, but today I want to explain how they actually work in a simple term. I will be answering a few key questions today. First, we will look at the vector database, what they are and how they are different from the traditional SQL databases we usually use. I will explain why they are so important for the AI model and what things like embedding, semantic search, and semantic score means when we talk about the technical competence to understand the human languages. After that, I will explain what RAG, Retrieval Augmentation Generation is, how it's work to give AI the right information, and how companies are using this tool in the real world. My goal is to keep this everyone simple and easy to understand. So let's get started. Here, our first question is what is vector database and how does it differ from the traditional SQL databases? So that is the great question. Basically, understanding the vector database, we first have a look at how we usually store the data. In a traditional databases, we store things in a table, row, and column. Actually, it is great. So extract matches like you want to find a student with a specific ID or a product with a certain price. It work on the structured data. So it is a very great. But there is a big shift when we talk about AI machine learning. When it deals with the images, long text, audio, we cannot just put them in a simple table. Instead, we turn that data into numbers called as embedding vectors. So when we use the vector database like a pinecone, where is pinecone? Using a vector database like a pinecone, Milias, and ChromaDB. So it does not look for the exact text matches. Instead, it looks for the similarity. For example, in a SQL database, if you search for dog, it only find the word dog. But in the vector database, if you search a dog, it might be also puppy or the golden retriever because it understands that the meaning is similar. So in the main difference are so search method. SQL use extract keyword, but the vector database use similarity search, like a cosine similarity. Then data type. SQL is for structured data, number and string, while vector database are built on the unstructured data, images, vectors, logs, and AI content. Hello, hello, hello. Am I audible? Yes. Can you see my screen properly? Yes. Hello, guys. Can you see my screen properly? Okay. So, data types use the SQL for the unstructured data, number and string, while the vector database are built on the unstructured data, images, sensors, logos, and the content. So, with AI, actually, if you're trying to do the similarity search in SQL, it would be a very slow. A vector database is optimized to handle the high dimensional math very quickly. That means in a modern application, specifically when you use a RAG or a recommendation system, we need vector database. That is nothing but a way for a computer to understand the relationship between the data points rather than just reading them as a plain text. So now we will go to the second question. That is why our vector database crucial in the age of the large language model. So actually to understand why we need a vector database, we first have to look at how the large language model works. An LLM is like a very smart person who has read the entire internet, but their memory is frozen on the day they finish training. So if you ask them about something that happened this morning, so they will not know it. There is also a limit of how much information you can text or an LLM at one time. This is called the context window. So you can just copy paste 500 pages or 1000 pages manually into a chat and expect it at remember everything perfectly. Basically, this is where the vector database come in the instead of trying to make AI memorize everything, we store our data in the embedding, which are nothing but numbers that represent the meaning of the text, like that. When a user asks a question, three things happen. First, we turn the text question into a vector. Where is user? User question like this. What is the process in the new manual? In the process of new manual, here is the manual. Chunking embedding here. Here is the convert vector data. Vectors, the chunks is converted into a vector and stored in the vector database. Okay. Then the vector database does the similarity search. It does not look the for extract word. Here, they search the similarity. Look at the exact word. It look for the meaning. Finally, it pull out the most relevant chunks of the information and feed them to the LLM. Because of this, we get three big benefits. First is a fresh data. Give three benefits. First is a fresh data. We can add new files to the database anytime and AI can see them instantly without needing to retrain the whole model. Then second is not hallucination. So if the AI has the real document right in front of it, it is much less likely to make things up. It is like open book exam. And third one is the scalability. So we can store millions of a document in a vector database like a pinecone, Milvus, and it can be find the right answer in a millisecond. So application of the RAG is personalized chatbot, up-to-date system, and domain-specific AI. So now we will go to the third question. That is, what are high-dimensional vector embedding and what do they represent? Now this is a great question to start with. Actually, the easiest way to think about the high-dimensional vector or what we call embedding is that they are just a way to turn word, images, or a data into number on a computer can understand them. Basically, computers are good in understanding the meaning of word, apple, but they are very good at math. So we present each word as a long list of the number. Each number is that list represented a specific feature or a characteristics of that word. Now there is a reason we call them high dimensionally. It is nothing but the saying that we are looking at the word from the hundreds of different angles at the same time. For example, if you have word, king, and dimension might represent quality, another might represent gender, and another might represent age. When you put all these numbers together, you get a point of the huge dimension space. That means word with a similar meaning will end up as sitting very close to each other in that space. For example, king and queen will be a neighbors, while a word like a smartphone will be very far away. When interviewer ask what they represent, you can simply say they represent the semantic meaning, the actual logic or the feel of the data. They allow a computer to calculate relationship because the data is now just number. The computer can literally do match like saying minus man, king minus man plus woman is equal to queen, like that. And summary, what they represent semantic meaning, the actual logic or fill of the data. Second is calculable relationship. The computer can do math on the data, the numerical language, turn data into the numeric computer understanding. Now we'll go to the third question like that. What is the semantic search and how it is different from the keyword based search? So that is a very common question, and actually the best way to understand it is by looking at how we search for things in a real life. So basically, keyword based search is the traditional way. It works by looking for exact and matches. If you type red shoes, if you type a red shoes, okay, in a database. But the problem is, if you type a crimson footwear, crimson footwear, it is like a red shoes, a red footwear. It might not show you any result because the word does not match exactly. Even though the meaning is the same, it is nothing but a simple word matching game. Now that is where semantic search come in the picture. There is a much smarter logic behind it. Instead of just looking at the letter, it tries to understand the intent and the context behind what the user is asking. When you are semantic search, we use something called as a vector embedding. That means we convert word and sentence into a number that represent their meaning. In this numerical space, words like shoes and footwear are placed very close to each other because they are related. So here is why they are different and better for the lot of the projects. So understanding meaning and intent. If a user makes a spelling mistake or the user synonyms, semantic search still find the right answer because they understand the concept, not just the text. Second one is the context. It knows the difference between the fruit, and Apple, the tech company based on the other word in the sentence. The next one is the natural language. Actually, it allows user to ask a question in a plain English, like they are talking to a person, rather than typing a list of keywords. So to summarize keyword search means about what word you type. But semantic search is about what it actually means. In modern AI project, we prefer a semantic search because it much more flexible and feel way more natural for the users. And your semantic search is a more natural. So understanding the meaning, context awareness, natural languages, like that. We will cover the next question. What is the common use cases of the vector databases? So actually, when we talk about the vector databases, we use it basically talking about how AI store and find the information based on the meaning rather than just keyword. Since you have since we have been building projects like Onion Guard and student placement predictors, you probability know that the handling complex data needs semantic smart than the regular SQL databases. Here is how I explain the common use cases in the interview. First is the retrieval augmentation generation RAG. Basically, this is the biggest use case right now. You know how everyone semantic mix things up or don't know about recent data. So when we use the RAG, we store all our document in the vector databases or as embedding. So when a user asks a question, the system does not just guess. Actually, it searches the database to find the most relevant chunks of information and feed them to the AI. It is nothing but giving the model as an open book exam. So it stay accurate and grounded. So second is the recommendation system. So there is also huge use of this the recommendation if you look at like Netflix or Amazon. They don't just match tag, they match user behavior. We represent every product and every user as a vector. That means if a user like a specific type of a movies, the database find other movies, they are the mathematically closed in that vector space because it understands the relationship between the item, the suggested much more natural and personal. Third one is the image and similarity search. Actually, this is very relevant to your in computer vision. Instead of searching by the file name, a vector database allows to similarity search. For example, if you have the image of a car logo, the database can find the most similarity logo by comparing their visual features. It is nothing but the comparing the fingerprint of the images. So see how close they are to each other. And last one is the anomaly detection. It is great for the security. When you have the millions of the transactions, you can store normal behavior as a vector. If your new transaction look way too different from the usual cluster, the system flag it immediately. So it is a very powerful tool for fraud detection because it can stop pattern that a human might miss. So next question. What are the some popular vector database or libraries you know? So four key categories explained below. That is the great question. Actually, I have been working on my AI projects. So I will realize that choosing the right vector database is a really important for how the system performance. Basically, there are four ways to look at this. You have to manage database that run in the cloud, and then you have open source libraries that you can run yourself. Popular managed database is there is the one that almost everyone mentioned first, which is the Pinecone. It is nothing. It is nothing but the fully managed service, which is great because you don't have a worry about the managing and any server. It is very fast and scalable easily, so it's a and production application. Then if we look at the open source side malwares and Vivid, they are very popular. Milvus is a huge in the industry because it can handle the millions of the vectors, and Vivid is also cool because it does not just store vector. It can also store regular data, which make it is very flexible. And lightweight and the local operations, when I am building the smaller project or just testing things out, I usually go to the Chroma DB. Actually, it is a super easy to set up. You can internally get the running with just a few lines of a Python code. It is perfect for the developer who want to move fast without a heavy setup. And we can forget about the face, which was actually created by Meta. Basically, face is the more of the library than the fully database. It is nothing but the collection of the every efficient algorithm for searching through vectors. So if you have the massive dataset and you need to find the similarity item really quickly on your own machine, Face is the best tool for that. Why we use them? That means depending on the what we need, whether it is a simple local project or a massive enterprise application apps, we pick the tool that fits. Because at the end of the day, all those tools do the same core job. They help the AI find the right information by searching through the vector embedding. So for my recent project, I'm mostly stuck with the ChromaDB for local testing, but there's something more serious. I definitely look at the pinecone. So we will go to the next question. That is the what is RAG? So RAG is stand for Retrieval Augmentation Generation, and here is the step-by-step explanation. Actually, RAG stands for Retrieval Augmentation Generation, and basically, it is technique used to make the large language model like a GPT more accurate. If I explain how it works step by step, it is nothing but the process where the model looks the specific information before giving an answer. Here is how it sees it. The problem is that normally an LLM is trained on the huge dataset, but does not know about the private file or the latest news. So it might be hallucinate or the given outdated information. The retrieval step, when the users ask a question, the system first goes to the vector database like a ChromaDB, which I have used in my project. It research through my specific document like attention paper in this file and find the most relevant chunks of the text. The argumentation. Now instead of just sending the user's question to the LLM, we combine it. We give the LLM the questions plus the retrieval text we just found is the context. The generated, finally the LLM read that context and generate the answer because it has the fact right in front of it. The response is much more grounded and accurate. So basically, it like giving an open book exam to an AI. It does not have to rely only on its memory because it can retrieve the exact information it needs from the custom knowledge base to provide the high quality professional response. Now the next question is the RAG model work. It is like an open book exam for the AI. RAG make us smart by giving access to outside information. Okay. So that is the great question. Basically, RAG stands for Retrieval Augmentation Generation, and it is a way to make AI smarter by giving the access outside information. This is, think of it like open book exam for this AI. Actually, the way it works is a simple step-by-step process. There is a clear flow from when you ask a question to when you get an answer. So first step one is the making the search easy. First we talk all the document, our document like a PDF or a text file and break it into small pieces. Then converted these pieces into numbers which is called embedding. So we'll store those in a specific place. That place is called as the vector database. Now step 2, find the right information. When you ask AI question, the system does not just gauge. It takes your question and look through the database to find the most relevant chunks of the information. This part is called the retrieval. Now the step 3, give one context to the AI argumentation. If the system finds the right information, it hands those pieces of the LLM, like GPT or OpenAI models, along with your original questions. It is nothing but the providing the AI with the context it needs so that don't have to rely only on its own training data. And there is a last step and the fourth step, that is the generative AI final answer. Generating the final answer is output. Because AI now has the fact right in front of it. It can write a very accurate response. That means the final response is grounded in a real data, which helps stop the AI from making things up, what we call hallucination. So to wrap it up, RAG is basically about the retrieving the fact first and then generating the answer. It's a very powerful way to keep the AI up to date without having to spend a lot of money in fine tuning or retraining the models. So in that way, we will go to the next question. How similarity score find? It is a number that tells us how close to similar to pieces of the data. So that is a great question. Actually, if you want to understand the AI, find the right information. We will stop here. Waiting. I have 10 minutes only, so we'll cover these questions. Only two questions, basically. So similarity score, it is a number that tells how close the similar to pieces data are. Here is the text vector, the basic comparison. That data must be converted into numerical vectors. Converting to numbers, when we have a text or images, the computer cannot understand them directly. So we convert them into the list of number called as a vectors. Then distance idea. If two vectors are pointing in almost the same direction, they give the high similarity score. That means the topic are very related. But if they are pointing for the apart, the score is low, meaning they have nothing to do with each other. Common matrix is that there is a very popular way to calculate this called cosine similarity. It is basically a math formula that look at the angle between two vectors. If the angle is small, the score is close to 1, very similar. If they are totally different, the score is closer to the 0. Because of this score, our system can rank result. For example, in a vector database, the system look at all the store data and say, hey, these three sentences have the highest similarity score to user query, and those are the one it pick. In that way, it will be work similarity score. Here, how to step by step cosine similarity solution. First, given information, vector 1 and that vectors are 0.8, 0.6 and data chunks in that way. And vector 2, 0.7, 0.7 data chunks 2. So, given two vectors, vector v1 and vector 2 representing the point. And we'll go to the next step, the formula. So, similarity score formula is equal to cosine theta is equal to vector 1. Here is a product of those vectors. Vector 1 multiplied by vector 2 divided by magnitude of vector 1 multiplied by vector 2. So step 3, calculate the dot product first, P1, vector 1 into vector 2. So here, vector 1, 0.8, 0.7 plus, multiply by 0.7 and plus 0.7, vector 1, 0.1. A1, A2, A1, A2, B1, B2. So A1 multiplied by A2, A1 multiplied by B1, 0.8 multiplied by 0.7 and A2 multiplied by B2. So 0.6 into 0.7 and addition is 0.98. So multiply corresponding element as some element and here step 3 has been completed. Go to the step 4. Calculate the magnitude length for this formula. Here putting this value. So magnitude of vector 1 is I am using the here Pythagoras theorem, square root square for the vector length. Here magnitude of vector 1 0.8 square and 0.6 square. 0.8 square is the 0.64 and 0.6 square is the 0.36. So we adding this, we will got under root of 1.0. That is nothing but 1.0. And here magnitude of same also same is calculated here. Magnitude of a vector 2 0.7 square 0.7 square under root of, and we got 0.49 plus 0.49, and we solved this, and we got under root of 0.98 is similar to the 0.19. So use Pythagoras theorem to calculate, and the final step, substitute this and substitute and divide. So now plug these numbers back into the main formula and simplify. Similarity score is equal to 0.98 divided by 1.0 into 0.99, which is equal to 0.99. So the high similarity point almost the same direction. Okay. And in that way, I have completed everything. So understand everything. That's cover all of the basic I want to share with you today. Thank you everyone for listening. Let me know if you have any questions, or we can just chat about any specific part you found interesting. Thank you everyone.